So let us solve 28th question of GATE 2019. Let me study the question. The table providing correct information about crystal structure, coordination number and packing fraction is to be found. And the abbreviations are FCC is face centered cubic, BCC is body centered cubic, DC is diamond cubic, CN is coordination number and PF is the packing fraction. So on the whole, we need to find the correct coordination number and packing fraction for face-centered cubic, body-centered cubic and diamond cubic structures. So before going to the solution, let me briefly discuss what coordination number and packing fraction means. So coordination number represents the number of nearest neighboring atoms or the number of atoms that are touching each atom in a unit cell. And atomic packing fraction represents the sum of volume of all the atoms in a unit cell divided by the total unit cell volume. So let us now find the correct coordination number and atomic packing fraction for FCC, BCC and DC. The schematic of body-centered cubic structure is shown here. And as we know, in body-centered cubic structure, the atoms will be touching along the body diagonal. And on considering the body-centered atom, the number of nearest neighboring atoms are 1, 2, 3, 4, 5, 6, 7 and 8. So the coordination number for BCC is 8. And on looking at the schematic of FCC, we can see that the nearest neighboring atoms can be found on each face, or the atoms will be touching each other along the face diagonal. So let us consider a face-centered atom for finding the coordination number. To visualize, another diagram is also given. On considering this face-centered atom, the number of nearest neighboring atoms are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So the coordination number for FCC is 12. The schematic of diamond cubic structure is shown here. On considering this section of the cube, we can find that the number of nearest neighboring atoms for this atom are 1, 2, 3 and 4. So the coordination number for diamond cubic structure is 4. So let us now calculate the atomic packing fraction for body-centered cubic, face-centered cubic and diamond cubic. For finding the atomic packing fraction, let us assume the lattice parameter as A and the radius of the sphere as R. The atomic packing fraction can be further written as volume of one atom multiplied by number of atoms in the unit cell divided by total volume of the unit cell. So this total volume of unit cell will be A cube, and as I already told, the atoms will be touching each other along the body diagonal in BCC. This length will be equal to 4 times the radius of the atom, which is also equal to root 3 times the lattice parameter A. So the lattice parameter can be written as 4 times the radius divided by root 3. The atomic packing fraction will be equal to 4 by 3 pi r cube multiplied by 2, because the number of atoms in body-centered cubic structure is 2, divided by A cube. So let us write the lattice parameter A in terms of R, which will be equal to 4 by 3 pi r cube multiplied by 2 divided by 4r by root 3 the whole cube. And on solving further, we will be getting the atomic packing fraction value as root 3 by 8 pi, which is equal to 0.679. Let us now find the atomic packing fraction for FCC structure, which is equal to volume of an atom, that is 4 by 3 pi r cube, into the number of atoms in the unit cell, and in case of FCC the number of atoms per unit cell will be 4, divided by the total volume of unit cell, that is A cube. As we know, the atoms will be touching each other along the phase diagonal in FCC, which gives 4 times the radius will be equal to root 2 times A. So A will be equal to 4r by root 2. On substituting the value of A in this equation, we will be getting 4 by 3 pi r cube multiplied by 4 divided by 4r by root 2 the whole cube, which on further equating will be getting pi by 3 root 2, whose value will be 0.74. So the atomic packing fraction for FCC will be 0.74. So let us now find the atomic packing fraction for diamond cubic structure, where this length is A and radius is assumed to be r. So the atomic packing fraction is equal to volume of an atom, that is 4 by 3 pi r cube, multiplied by number of atoms in diamond cubic structure, that is 8, divided by the volume of unit cell, that is A cube. In diamond cubic structure, these two atoms 1 and 2 will be touching each other, and this length will be equal to 1/4 of the body diagonal. As we know, the body diagonal length will be equal to root 3a. From this length we can say that 2 times the radius will be equal to root 3a by 4. So the lattice parameter a can be written as 8r by root 3. Let us substitute this value in this equation. We will be getting atomic packing fraction as 4 by 3 pi r cube multiplied by 8 divided by 8r by root 3 the whole cube. On further solving, we will be getting root 3 by 16 pi, which will be equal to 0.34. Therefore, the atomic packing fraction for diamond cubic structure is 0.34. So the correct option in this question will be option A.